Hi everybody, today we are talking about adding and subtracting complex fractions. So our goal is simply to add and subtract complex fractions. Now, what do I need in order to add or subtract fractions? And this goes for any fraction. You need a common denominator. Otherwise, you're not allowed to add or subtract them. And then what other important information must I remember? How to factor. You need to know that, so if you don't right now, if that sounds like something you've never heard before, we might need to go back and study some stuff. So there are some steps. I'm going to walk through this. First is factor if possible, find the least common denominator, multiply by missing factors, combine like terms in the numerator, and factor again if possible, and then cancel factors if necessary. So you'll get it. So number one, the first thing we need to decide is, do they have a common denominator? Well, I have a 3x and a 3x, so they do. So I've skipped one, can't factor it. Find the least common denominator. Well, we already have it. So I can combine like terms in the numerator. So that just becomes 9 over 3x. And then we can reduce this, though. 9 divided by 3 is 3 over x. So again, that last step would be to cancel any factors. That's what we're doing, just reducing. All right, example 2. So the first thing I need to know is my least common denominator. So to find that, I like to look at, okay, what does the first fraction have that the other one doesn't? Well, x minus 4, and then this one has an x plus 3. So if I just multiply those together, that's my least common denominator. So that would be number 1 and number 2. I'm not going to do that because we're going to go through this more times. Then multiply by the missing factors. So the first term, does it have this x minus 3? So I need to multiply top and bottom by x plus 3. It has to be 1, you have to do top and bottom, and it has to be the one that's missing. So say with this term number 2, I have the x plus 3, but what I'm missing is the x minus 4. So again, top and bottom, we're going to multiply. And you know what, I'm going to zoom in real quick, give you a better view. So what happens is, on the top, I'm going to distribute my x, so that gives me x squared plus 3x over, and we're not going to multiply the bottom, because we might need it factored later, minus, well, what I'm going to do is I'm going to change it to a plus and make my 6 negative. And then I'm going to distribute my 6. So that gives me negative 6x plus 24. And then my denominator is common now. And they should be the exact same. Otherwise, I'm doing this for nothing because it's the only way I can put them together. So that brings me to my next step, which is to, let's look, combine like terms in the numerator. So I'm going to combine like terms. So that gives me x squared minus 3x plus 24 over x plus 3 over x minus 4. So you always, once you get to the most simplified part, which is here, we need to try to factor. But it doesn't always work. So right now I'm on step 4, combine like terms, no, step 5, factor again if possible, and then cancel factors if necessary. So I'm going to try to factor again. I need something that multiplies 24 and adds to negative 3. So think about that for a second. Multiplies to 24 and adds to negative 3. I don't know, like 12 and 2, 6 and 4. None of these are going to work. So that one we can't factor, and that's okay. Sometimes that happens. So we're at our final answer. Okay, example 3. So step 1 is to always factor if possible. So I need to factor the bottom. And I need two numbers. In this case, this is a 1, so that multiply to 9 and add to 6. And by guess and check, I'm going to get this answer, x plus 3 times x plus 3. But remember, you need to know how to factor. So this is a difference of squares. So I know that my pattern tells me it's x plus 3, x minus 3. So I need a least common denominator. So let's look at this side. What does this one have? This one has an x plus 3, two x plus 3s. And then what does this one not have? Well, it has another x minus 3. So we don't need to use all 3 of the x plus 3s, right? The most one factor has is 2. So then this side is going to need 2. So that's why I have 2 in my least common denominator. And then my first term didn't have that x minus 3, so that's why it's included. So just take a second if you need to rewind that again. We're just finding the least common denominator. So then we need to multiply by what's missing. So what's missing on this side is an x plus 3, right? Because I need it to have 2. So I'm going to multiply top and bottom. And then on the first term, what am I missing? The x minus 3 and x minus 3. So now I can multiply these together and my denominators will be common. So I have to FOIL the top here. I've got a binomial multiplied by a binomial. So that gives me x squared. That's negative 3x plus 1x is negative 2x minus 3. And just like the last one, I'm going to make that 1 negative. I'm going to change the middle term to the middle symbol to a plus and bring that over to the negative 1 when I distribute. And this is going to be over x plus 3, x plus 3, x minus 3, because that's my new denominator. And then up on top on the other one, I've got negative 1x minus 3. You don't need the 1, but I wrote it anyway. Over x plus 3, x plus 3, x minus 3. So now that my denominators are common, I can combine like terms in the numerator. So that gives me x squared minus 3x minus 6 over x plus 3, x plus 3, x minus 3. And then again, try to factor. We don't want to forget that part. It's important. It's our last step. And we need something that multiplies to 6, but also adds to negative 3. So I've got 1 and 6 and 2 and 3. Neither of those are going to ever add to negative 3, so I can call it a day. All right. Example 4. Step 1 is to factor if possible. So I'm looking at this denominator here and saying, yeah, I think I can factor that. So 4 over 3x to the third over x over, okay, I'm going to find my greatest common factor. So I can take out a 3, and I can take out an x squared, then I'm left with 2x plus 1. Remember, 3x squared divided by 3x squared is 1. You have to put that 1 there. So when I look for my least common denominator, I'm looking, what do they have in common? Well, this one has a 3, and this one has a 3. And then I'm looking at this x to the third, but this one only has an x squared. So I have to go with that x to the third. That's important. And then I have this 2x minus 1, plus 1, excuse me, that this one has, but this one doesn't. So in order for them to be common, every single part must be included in my least common denominator. So when I look at my least common denominator, I need to figure out what's missing from my given fraction. So compared to the least common denominator and this denominator in term 1, what is it missing? Well, it's missing that 2x plus 1 term. And again, we have to multiply on top and bottom. If I look at term number 2, the 3's match. This one is, I need it to be x to the third, and this one's only x squared. So I'm just going to multiply by x over x, because that's all it's missing is 1x. So if I do x squared times x, it gets me to x to the third, right? I'm just trying to get to the least common denominator. So now I can multiply it out. So I've got 8x plus 4 over, and again, I'm going to leave my denominator. I don't want to multiply that yet. Plus x squared, x times x is x squared, over 3x to the third times 2x plus 1. Now my denominators are common, which is, of course, the goal to adding any fraction, whether it's 1/2 plus 1/4, you need a common denominator. And then you can combine like terms in this numerator up here. So x squared plus 8x plus 4 over 3x squared, times 2x plus 1. And then you're all thinking, what's that last step? Let's think about that. Well, we must try to factor, and we cannot, so I'm going to circle it. But again, remember, try to factor at the end. That's the last thing you do before you can be done. But we don't find anything that multiplies to 4 and adds to 8. It's not happening. All right, I've got one more example. And again, I need to factor if necessary. So the only one I need to factor is that middle one. So again, it's a binomial, not a difference of squares or anything, so I'm just looking for the greatest common factor, which is 4x, which gives me x minus 3 minus 4 over x minus 3. So least common denominator. Now I have a feeling that this might be the tricky part for everybody, so I encourage you to rewatch this and just try to make sure you know where these least common denominators are coming from. So we need to find first the least common multiple of 6 and 4. So I could, it doesn't necessarily wrong if you don't choose the smallest number, but sometimes it's easier to break this down. I know that 6 is 3 and 2, and 4 is 2 times 2. So what do they have in common? A 2. What do they not have in common? 1, 3, and another 2. Or you could think about, okay, what two numbers, the smallest number, can you is a factor of a multiple, of 6 and 4. It's 12. Right? 6 times 4 is 24, but I know of a smaller number that's divisible by both 6 and 4, and it's 12, which is the same thing that I get by multiplying these together. And then I think about what else they have. Well, this first term has an x squared, and the second one has an x. So the x squared has to be in my least common denominator. And then the second term and the third term both have an x minus 3. So however you want to think about it, we're finding the smallest number or variable that's divisible by each thing in our fraction, in our denominator. So I need to find the missing piece and multiply them. So the first term is missing, well, what do I multiply by 6 to get to 12? 2 times, well, it's missing that x minus 3. So on top and bottom, I'm multiplying by 2 times x minus 3. And then this middle one, okay, what do I need to multiply by 4 to get to 12? 3. And I need an x because I have to get back to x squared. So 3x over 3x. And then the last one, I have this x minus 3. So I'm going to need to multiply by 12x squared over 12x squared. Excuse me. So now I'm going to multiply. 5 times 2 is 10 times x minus 3 over 12x squared x minus 3. And it should check out that it's the same after you multiply here. Otherwise, we might have done something wrong. Then I've got times 3x squared over 4 times 3 is 12. X times x is x squared times x minus 3. Plus, I'm going to change it to plus negative. 4 times 12 is negative 48 x squared over 12x squared times x minus 3. So double check, make sure you know where all these values are coming from. And right now, I'm going to simplify this right here. I'm going to distribute that to be 10x minus 30. So what I can do is combine like terms in my numerator. So that gives me negative 45x squared plus 10x minus 30 over 12x squared times x minus 3. So it's important that we try to factor. So the first thing I notice is I have a greatest common factor up top, and it is negative 5. So that gives me 9x squared minus 2x minus 6 over 12x squared times x minus 3. So we also need to make sure we factor the inside if we can. So bonus round, on your own, you're going to see if you can factor that and see if anything cancels. So factor, you're going to do step 5. Factor and cancel if possible. Whoa, I'm screwing up here. If possible. Do the best you can, try it, see where you get, and we'll talk about it when we get back to class. See you then.